So we look for planets in many different ways. Our search in the identification of bodies, of planetary bodies that orbit stars other than the Sun, is very diverse. We use many different techniques that exploit both the law of gravitation to look for tiny, minute signals that we understand as being due to the presence of an orbiting companion around another star. And in this way, we have today identified more than 5,000 planets orbiting stars that are different from our Sun. The search for stars orbited by planets that are really like our Earth, what we call Earth twins, is the hottest topic probably in our field. Our field is very young. We have discovered the first planet only 28 years ago. And since then, the field has really boomed. And the frontier of the field is really identifying true analogs of our Earth. We know now that they are abundant in the galaxy. It is possible that maybe 1 star in 5 in our galaxy hosts a planet like Earth. And so the fact that they are so frequent is boosting our technology development to identify them and study the properties more and more clearly. We know, for example, of the nearest stars to the Sun. We call it Proxima Centauri. It is a tiny red dwarf. It is very, very small. It's much lower luminosity star than our Sun, but it hosts a planet that sits exactly at the right distance, the same distance that separates the Earth from our Sun. And there we have identified, orbiting Proxima Centauri, a planet with a mass close to the mass of our Earth. This is a first clear example of an Earth-like planet that we have just found next door, which tells us a lot about the frequency of these companions and the fact that, being so abundant, the chance that at some point we will identify some of them hosting potentially life at the surface is indeed high. So the next step that we will take will be indeed to look for signatures that can tell us about the presence of life in these planets. To do this, we will not need only to know that the planet is there, it has the right mass, it has the right radius, and it has the right distance from the star, but we will need to study their atmospheres. To study their atmospheres is something that is extremely difficult and we cannot yet do today. We can today study the atmospheres of objects that are much bigger than the Earth, giant planets orbiting other stars. This is something that is achievable today. But in the next 10 to 20 years, we will develop sufficient technology to, in fact, address the question of the existence of atmospheres around rocky planets like us and see if they can contain what we call biosignatures, molecules in the atmosphere that identify unambiguously the presence of life on the surface. So this is really the frontier of the field that we can expect to eventually pass in the next decade or two.